Hi folks, welcome to today's webinar. My name is Matt Fleming. I'm the VP of Field Marketing at Newtonian. Today we will be discussing how you can predict or classify evergreen content using Eureqa, machine learning, and data provided by StumbleUpon for a recent Kaggle competition. With that being said, let's get started. Great, so we can get started by opening up the Kaggle.com competition page for StumbleUpon. Let's talk a little bit about what they were trying to accomplish with this challenge. So what StumbleUpon was essentially trying to do, they wanted to build a classifier or an algorithm that could categorize web pages as being either evergreen or non-evergreen. For those of you who don't know what evergreen or non-evergreen means or what they signify, evergreen typically refers to content or a website or web page that stands the test of time and that the content is always authoritative and tends to drive return traffic year after year. It's timeless. So for companies like StumbleUpon, whose whole product is essentially a web content discovery engine, being able to improve upon that engine's ability to find and display good content is incredibly valuable to them. Let's take a look at the data. You can go ahead and click that from the left-hand menu. Relatively straightforward. StumbleUpon included your test and training data. We'll primarily be working with the training data today, so you can go ahead and download that now. It's in a TSV file. There's a bunch of other kind of files that they include there, like a sample submission if we were to be participating in this competition. Let's take a look at some of the variables. So the variables that StumbleUpon included were everything from the URL to some of the boilerplate text. It's actually in JSON format, so we'll talk about that in a second. Different types of classifying what category the website is, and a lot of quantitative metrics as well. So link ratios, embed ratios, frame tag ratios, a bunch of different ratios basically comparing kind of text and HTML on the page as well as other elements like iframes and stuff like that. What we really care about though is that last label, especially within the training set. Or the last variable, which is label. Label corresponds to whether that website was deemed to be evergreen or not. So that is essentially going to be the variable that we're going to try to predict. So go ahead and download the training set and the test set. Again, we'll be working with the training set. And go ahead and open that within Excel as well. I've opened up the training data within Excel so we can take a little bit of a look at it. Immediately what you can see, and what's probably going to present the biggest issue for us, is the fact that the boilerplate column, or the boilerplate variable, is a JSON object. So what that means is we're going to need to parse out the different elements that are contained within it. For reference, it's title, you can see that up here, body, and then actually at the very, very bottom is another object or element marked URL. We want to parse out all of those so they're in their own separate column. Or columns. What that will enable us to do is it enables us to see what words in what positions within the boilerplate may or may not play a role in predicting evergreen content. Additionally, one thing I did, although it's not necessarily critical, is to go ahead and parse out the domain from the URL. That could be interesting. Again, we're trying to find content or evergreen content, and evergreen content is content that stands the test of time. So for instance, if the domain was 500recipes.com, maybe that might play a role in predicting evergreen content. So I went ahead and parsed that out. We made available our project file, which has all this stuff already done for you, so you please don't feel you need to walk through all of the parsing. We do that for you, and the file's available in the blog post. Okay. So once all this is done, you would go ahead and save it as a CSV file, and then you can go ahead and import it into Eureqa. Let's go ahead and do that now. Okay, so I have the training data now loaded into Eureqa. Just to show you guys how I did that, I went to File, Import Data, and then imported the CSV file. Your variables might be in slightly different order than mine. As long as they're there, you're okay. So just to reiterate, you can see the domain column that I split out from the URL. And then if we scroll a little bit to the right, we'll see how, or those columns that we parsed from that JSON boilerplate object, title, body, and URL. Now again, the one we actually care about predicting is label. That's the one that corresponds to whether content's evergreen or not. Let's go ahead and take a look at the different data preparation options we have within Eureqa. So within Eureqa, there's a few different options for preparing data. The way we typically approach modeling data for the first time is to not do too much data preparation. So for the purposes of this tutorial, we won't. But just to give you guys an idea of the different options that are available, you have the ability to handle missing values in a few different ways. You can either replace it with the mean or ignore the row. There's a few other options there as well. We can remove outliers, we can normalize the scale, we can filter out data, we can smooth data. So there's essentially a lot of the core data preparation tools built into Eureqa. Again, for our purposes, we're not going to really touch those, at least for this attempt. It is worth noting, which you may have already noted, that there seems to be a lot of new variables that were appended to our training data. That's actually intended. The way Eureqa handles text data that's non-categorical is to pick out the most frequent. It basically uses a bag of words implementation that essentially finds the most frequently occurring words within that variable and then appends them as Boolean columns to your training data. So for instance, if a record had the domain of space.com, this variable would have a 1 or a true value. Okay, so we've talked a little bit about the different data preparation options. We're not going to do too much for this tutorial. Let's go ahead and start thinking about how we're going to define our search. Let's click the Define Search button or the Set Target button, depending on what version of Eureqa you're using. The Set Target screen is really where we set the parameters for our search in Eureqa. You may have noticed a few different elements. There's the target expression, the building blocks we use, or the building blocks Eureqa uses, or operators that it uses in constructing the models to fit your data. There's error metrics. We have a few different error metrics available to us. For the purposes of this tutorial, we're going to use AUC, or area under curve. We have the ability to set up row weighting for data if we were trying to model data that didn't appear too frequently within the training set. And we also have the ability to set custom splits in terms of training and test data within Eureqa. Actually, lastly, you may notice the base and prior solutions. What that gives us the ability to do is if we had already modeled this data or had a pretty good idea of what starting point we wanted Eureqa to begin its search from, we could enter that there. Let's talk a little bit deeper about the target expression. So this is a slightly more complicated one. I know this might look a little daunting. You could easily go ahead and just set this up as label as a function of all these other variables. So it would literally be label equals f of ... In this case though, we decided to make it a little bit more complex. We decided to model label as a logistic function simply because the values we're trying to predict are either a 0 or a 1. So I'd encourage you guys to do the same. In terms of the mathematical building blocks, let's talk about that a little. Since this isn't time series data, there's really no need for your trigonometric functions or trigonometry. So sine and cosine, they come enabled by default. I went ahead and disabled them. I'd go ahead and turn on the logistic function, as mentioned, because we're trying to model label as a logistic function of all these other variables. And then lastly, I'd go ahead and turn on the logical variables. You don't need to. It's just it might be interesting because we're dealing with different combinations of words in different places. It may turn up to be impactful, but it may not. Great. So we've gone ahead and set our target expression. We've picked out what mathematical operators or building blocks Eureqa is going to use in building these models. We've selected our error metric, and we've decided that we don't need any row weighting. We're actually all set to go ahead and start our search. We can do that by either clicking the play button in the upper right hand corner, or we can click the Start Search tab and click Run. I've already actually run this. So there's a few different elements on the screen that are worthy of explanation. On the left is progress and performance. We can start with that. Search time, pretty self-explanatory. It's how long we ran the search. For this tutorial, we ran it for a little over 3 hours. CPU cores, that's the number of cores that are available to Eureqa. For this tutorial, as mentioned in our blog post, we ran this on a 72 core private cloud. You have the ability to actually set up your own private clouds as well using the secure cloud. You only pay for what you use. So I'd highly encourage you guys to check it out. You can spin up 100 cores for something like $30. Performance, that's essentially giving you an idea of how many generations or models Eureqa's gone through. In the case of this search, we went through nearly 700,000 models. Obviously, not all of those are displayed on the results tab. We only show the best ones there, but that gives you an idea as to how many models Eureqa's actually crunched through. Confidence metrics, those are really just trying to give you an idea of, or trying to answer the question, hey, is it a good time to stop my search yet? Just trying to give you an idea of the stability and maturity of your model search. Progress over time, essentially what this is trying to give you a visualization of error as it decreases over time as new models are found. And what we typically pay attention to at Newtonian are the big drops. So the big drops typically are when Eureqa latches on to something significant in the model or finds out a core truth about the model, I guess you could say. So for instance, for us, stuff like this moment in time right here, this moment right here tend to be, and actually here as well, tend to be very interesting for us in terms of what Eureqa's latched onto. Project log, this is just giving you an idea of the solutions as Eureqa comes across them, as well as the status of any cloud servers that you may have up and running. Let's go ahead and jump to the results tab. I went ahead and jumped to the View Results tab. So the View Results tab is where you get a digest view of all of the solutions or models that Eureqa's created throughout the course of its search. They're displayed in this window right here on your left, and they're sorted using a ratio of complexity versus accuracy by default. You do have the ability to sort by fit or complexity alone, should you so choose. And for the purposes of this demonstration, I selected the topmost solution just so we can talk through the different windows on this screen. In the bottom left, these are all the error metrics that are available to you, or basically summary statistics that are available to you. We have R-squared, goodness of fit, correlation coefficient, mean squared error, mean absolute error, and we also have the primary objective. So the primary objective is basically the error metric that we used. In this case, it was AUC. On the right, we have a graph of all of the solutions, essentially on a scale of error versus complexity. So as solutions become increasingly accurate, they also become more complex. In this case, I'm looking at the most accurate solution, which is signified by this red dot. In my personal opinion, this is where domain experience comes in handy, simply because it allows you to decide or kind of make the trade-off between accuracy or predictive accuracy and complexity. Some of the considerations you might want to take into account are whether or not this solution needs to be scalable. If this is a model that you're going to be using every once in a while, it doesn't make sense not to go with the most accurate solution. However, if you're going to be using this model millions and millions of times, you need a solution that scales appropriately. In the upper right, we have different ways of visualizing the error or accuracy of the solution or multiple solutions, and I'll show you that in a second. I'm looking at an ROC plot, but you have the ability to look at a solution fit plot, view observed versus predicted, residual error. There's a few different ways that you can view kind of how these solutions fit the data. Just to show you something else, you also have the ability to view multiple solutions at the same time. So you can go ahead and compare error metrics across your top 3, 4, 5 solutions, and then also see how they're visualized on the different graphs that we have available on the screen. Let's take a look at one of the actual solutions. Interestingly, they all kind of share a similar theme, I guess you could say. I'm looking in this window right here. What we found over the course of 3 hours, not to say this would be the final results, but what we found was that when the URL contains words like butter, cake, chicken, kitchen, recipe, or recipes, those tend to have a positive impact as to whether or not the content should be considered evergreen or not, which is very interesting. So that's one of the advantages of using software like Eureqa, is that you're not only going to be getting a prediction, but you're also going to be given a model that helps you understand not only what variables are important, but also how these variables relate to one another, what type of impact they have. And I think that's incredibly important when you start talking about prediction and machine learning. We can go ahead and jump to the Reports tab. I'm going to go ahead and run a summary report just to give you guys an idea of what it looks like. What I love about the summary report is that it gives you a very quick, immediate view of what variables are important and what variables are not, basically showing how they're used across the various models. So we can see immediately that URL variables tend to be very important, while domain does not tend to be very important, as well as some of the other variables that we found. Additionally, as you kind of scroll through the bottom of this, you have the ability to see all the models as well as kind of their different error metrics or a visualization of their error metrics. Also from the Reports tab, you have the ability to run a selected model against a given data set and get all the error metrics back from it. That's very helpful. Other kind of tools that I use on this screen are the quick evaluate and predict values. I find that very helpful as well. Last but not least, before we kind of jump into wrapping up this tutorial, I want to take some time to talk about the Secure Cloud. So as I mentioned, we ran this search on 72 cores. What the Secure Cloud enables you to do is it enables you to basically get more processing power so you can find results faster and you only pay for what you use. It does require setting up an Amazon account, but we're happy to help you with that as well, and I highly recommend doing it simply because for $30 you can spin up 100 cores and find results to a problem that would otherwise have taken you a couple months to figure out if you were to do this without Eureqa and try to do it manually. So again, definitely check out the Secure Cloud. So with all that being said, we've talked through the results, we've talked through how you can better understand those results and share them with coworkers using some of the reports. I think it's time to start wrapping up. Well, folks, thank you very much for joining me today. If you have any questions, please do not hesitate to ask. You can contact me directly. My email address is matt.fleming@newtonian.com. Alternatively, you can email all of us just by sending to contact@newtonian.com. Whether it's a technical question on how to use Eureqa or how to model your own data, or even if it's trying to learn a little bit more about pilot studies or some of the custom consulting we do, please don't hesitate to ask. Thank you very much, everyone, and have a great rest of your day.